Shall I tell you about this? This is the Sennheiser, the new Sennheiser 9000 digital wireless microphone system, comprising the EM9046 receiver system, SKM 9046, SKM 9000, I beg your pardon, handheld microphone, SK 9000 body pack transmitter. So it's a digital, fully digital wireless microphone system, no analog elements involved other than outputs and the inputs. So we're doing the analog to digital conversion in the transmitter, 24-bit conversion within the transmitter, transmitting it completely digitally. We've got two modes. The most important one, I guess, is the HD mode, which is the uncompressed digital transmission. So no data compression at all involved in the HD mode. So 24 bits of uncompressed digital audio. AES outputs at the back. You've got the option on the back of the receiver of AES outputs and analog. There's room in the back. There's two modules in the back with room for. On the analog module, you get 8 XLRs, transform balanced outputs, and on the AES module, you get 2 rows of AES, and on each module is a D-type which has the same again, another 8 analog on the analog module, or another set of AES digital outputs on the digital module. You can put 2 digital modules in and have 6 AES outputs, 6 sets of AES outputs, or you can put 2 analog modules in and have 4 lots of analog, all transform balanced. That's on the RF side, the radio side. The most important features are things like spectral efficiency now. We're being squeezed a lot on spectrum, frequencies, available frequencies. So with this system, we can fit 40 channels, 40 radio mics into 24 megahertz, where previously we would have only fitted about 20, best case. Typical analog, best case, about 20 channels in 24 megs. With this system, we can do 40. We've got very linear output stages in the transmitters and ferrite isolators in the outputs, so we don't have to worry about intermodulation anymore. I spent 10 years telling everybody about how important intermodulation is and frequency planning. Suddenly, tear up the script as far as this is concerned. 40 channels, when I say 40 in 24 megs, that could be 40 equally spaced carriers. Still fitting within the 200 kilohertz ETSI mask, so it's still fitting in the standard 200 kilohertz radio mic channel, so it can coexist with other UHF equipment. Receiver tunes all the way from 470 megs, channel 21 in the UK or in Europe, all the way up to 798, which is channel 61 in the UK and Europe, all in the same receiver. Transmitters tune across 88 megahertz of bandwidth, so we need several different transmitters to cover the entire range. So the other innovative feature, I guess, is that the receiver communicates with the antennas, the active antennas, or active boosters that we use. They're a new device, 9000 series boosters and antennas, completely new. The receiver communicates with those along the coax cable, the RF cable, and then it can measure the loss along the cable and compensate accordingly. So if you've got different lengths of cable on the 2 antennas, it will compensate accordingly to equalize the RF strength at the receiver from both antennas. It also controls the filters in the antennas. That's remotely controlled through the coax from the receiver to pre-select a 24 meg window in the antenna, depending on what you're using. You can daisy chain the RF from these receivers to 4 racks at a time. So you can daisy chain 4 racks. Each of these racks is 8 receivers. There are in fact 8 separate receiver cards, so you can change the cards inside, or have less than 8 if you need to have it not fully populated. We expect most people will have it fully populated. This display has the facility to do a lot of things that we've typically done with a remote computer in the past. We can use it as a spectrum analyzer, we can do RF recorder functions all from this display. What else should I be telling you about it? Oh yeah, lithium-ion batteries. The main batteries for the transmitters are all lithium-ion technology, lithium-ion rechargeable technology. So it's very tightly integrated. When we use the lithium-ion batteries, we can have very good battery status information both on the transmitter and transmitted to the receiver. so we have very accurate information. There is an alkaline battery option, which you can use as a spare wheel, as Sennheiser like to say. So the lithium ion is the main normal usage, and if we're in an emergency or we've got a longer rehearsal period or something, we can use alkaline batteries instead. Or, as well. So the lithium ions will give us over 6.5 hours of operation anyway on one charge.
Can you explain to me, this is not my field, but the audio you're transmitting is digital already?
Correct, yes.
So why is it significant that it's uncompressed? Because surely it's just data, it doesn't matter, does it?
Yes, it does. Because it's particularly in the broadcast world where you may be compressing the file later and then uncompressing it in different formats.
So is it the process of compressing and uncompressing that?
Process, depending on the type of audio compression you use, you can be essentially throwing away information. So if you decode, say an MP3, and then re-encode it and decode it, each time you do that, you're throwing away some information, and you get what's known as concatenation problems. So starting off with completely uncompressed audio means you're never going to have that problem. There's nothing been thrown away from one end to the other. It's exactly the same as using a wired mic in that sense. It's 24-bit. On the outputs, you can have anything from 96, 88.2, 44.1. I missed out 48, didn't I? Yeah. So
what's it between the transmitter and the receiver?
I forget, quite frankly, the exact rate between the two ends, but it actually samples at 42k 24-bit in the transmitter. And if I remember rightly, it's actually 96k between the transmitter. That seems a bit weird. It's 96k between. It's come back to 96k between the transmitter and the receiver, even though it's sampling at 42.
What's critical is analyzing frequencies and how things work in a radio environment. How can you do that? Can you really have an analyzing system to it? And if somebody comes in with a system like an EEG camera, how can you then measure it, and how can you?
Yes, that is quite tricky. That is quite tricky. That hasn't changed, I guess. That doesn't change from the analog to the digital world. There's still that unpredictability. The best way of dealing with that is frequency planning. For example, in this country, we expect most people working in this scenario would be using channel 38. So if you're planning a large event, most people will avoid channel 38 with their radio mics, but there's really very little we can do about that. Other than that. However, the digital transmission is very robust, so that would shrug off a lot of interference in ways that analog can't.